Welcome back, Trivers. So I thought I'd do a bit of an update video on this inverter. It's been a couple of days and I haven't really done anything. Thanks again, and a big thank you really to everyone that commented on the last video. All the comments were really useful and really handy, so thanks again for that. So progressing on a little bit further now, what I've done is I have desoldered the MOSFET from the top area. I didn't actually notice the little burnt kind of mark that was on the inside of the case. It was really hard to notice when I was videoing it, but yeah, obviously quite visible in the video when you watch it back. So yeah, I didn't even notice that, so thanks for pointing it out. But it was actually the component that I first noticed to start with, so I have desoldered that now, and if I try and zoom in a little bit, you might be able to see where it's come out of. Now what I'll do is I'll just show you on the screen what the component looks like. This is it here, but I'll show you on the screen blowing up. And as you can see, the MOSFET itself, that solder on those last two pins, pin 2 and 3, I'm pretty sure that wasn't there to start with. It looks like it's kind of soldered, maybe they had too much solder to start with and it's kind of melted its way together. Not really too sure about that. It just seems to be an awful amount of solder in a little spot. Now, as you can see, this is, I'll bring up also the data sheet, or the first part of the data sheet. It's a 33 amp in-channel MOSFET. So there's two of these actually. So if we come back to the video here, you'll see that this is obviously one where I've taken it off, and there's another one identically on the other side. So I thought, well, if one's blowing, maybe the other one's blowing. If I'm going to have to order one, well, let's first check that the other one is okay or not. So I have desoldered the other one, mainly because I actually couldn't see enough details on the part, but it turns out that I only need the first four letters, or four characters, to be able to Google the data sheet, so that was good. But as you can see, looking at this MOSFET on this side that I haven't desoldered yet, and if I put a little light there too, it's going to be a little bit hard to see, but you can see that there's a white mark, and this one's got an issue exactly the same place as the other one that I have desoldered. I'll try and get a better camera angle. So I can't really get a good angle on that because it's so dark, and to try and get that in focus, it's just not working. But you get the point. I need to take that one out as well. Now the other thing to mention is, when this came out, because I had to desolder it from the bottom and kind of tug on it, it also decided, and you might be able to see this here when it comes back into focus again, it also pulled a bit of the trace out, or the track from the top part of the circuit board. Obviously it's a double-sided circuit board, and it's pulled off the a part of the trace from the top. Unfortunately, what that means, however, is that if we come back over to here again, you can see where that got burnt. You can also notice that now that trace went under the heatsink, and what that means is that I'm going to have to pull the heatsink off to get access to that trace again, to resolder it from the top when I put the new one back on. So and I'm guessing the same thing's going to happen when I desolder this one here. So the whole heatsink really has to come off, which does mean unscrewing each of these, which is what I found this long screwdriver for, and that appears to work. So I'm going to unscrew each of these. I'm also going to visually check all of these and check that they are okay, which I suspect they will. I suspect that the only two components that blew are these N-channel MOSFETs on this end, but I suppose the question, it's really a guess at this stage, so I'll do that. So really at this stage I suspect the actual problem came from the unit overheating on this part of the heatsink. So when this unit sits on the wall, it sits up like this. Oops, there goes that MOSFET. But anyway, it sits up like this, and the fans blow up through the inverter, and the heat comes out the top here, and it gets sucked in the bottom. So sucked in the bottom, blowing out the top, that's not so bad. And it's got that fan there, and it's got two fans here. But unfortunately what's happening is that this heatsink here and this fan aren't able to remove enough heat from all these, I'm guessing the MOSFETs or whatever else they are in here, diodes and other bits and pieces. And obviously the ones at the very top, which is obviously the top of the heatsink, are getting the hottest. And I suspect that's actually what killed these MOSFETs more than anything else. Because they're 33 amp MOSFETs, there's two of them. We were drawing around 30 something amps, and so that means that they're about 15 amps per MOSFET, in which case they're well under the spec of 33 amps, which is good. But it does mean that once they get hot, then obviously they can't tolerate as much current continuously, and I suspect that's what's actually killed them. So what I'll do is I'll also show you a graph of how much power we were using at that period of time. And as you can see from the graph, you can see about an hour beforehand we were using the inverter was putting out quite a lot of power because the house was using a lot of power, so it was putting out a lot of power. And you can see it sat at about 1900 to 2000 watts continuous for about or for whatever length of period that is. And you can also see it dropped back down again because obviously whatever appliance was turned on got turned off, and then it obviously something else got turned on, and then it kind of decided it obviously ramped back up again, and then that's when the problem happened and it blew. So I'm actually quite surprised that it didn't blow after, well, when it was consistently putting out 2000 watts or 1900, 2000 watts. It blew actually after it dropped back down again, so I would have thought it cooled off. But either way, that's kind of the only thing that I can think of that could have caused this to blow. It was having a bit of a hard workout that day. And yeah, I can't really think of what else could have caused the problem. The MOSFETs look genuine MOSFETs. They don't look like a rip-off, Chinese rip-off of one. But who knows? So we'll replace them and then kind of go from there. But so anyway, let's unscrew this and see what else we can see. I'll pull that MOSFET that fell down, and looking at this closer, not on the camera but closer, the same thing doesn't look like it's happened to this one here. I can't see any joint of solder joints or anything like that on the component that's in here. So this looks like it kind of seized itself together somehow. Right, so this is how it looks taken apart. It's actually a double heatsink. They're kind of stuck side by side with the fins facing each other. Each of the MOSFETs screw to the board with looks like a isolator on each of them. So I've got to make sure I put those back. The only ones that don't have isolators are these N ones, and as you can see, this one here has got the burnt stuff over the bottom of it. This one here has got no burnt stuff, but obviously that MOSFET's dead. In fact, that's actually the isolator thing on that, so I do have to make sure that that goes back onto that. Now each of these, what I'll do is I'll just gently bend that over and I'll take a photo of it because it's probably going to be easier than trying to zoom in and out on the camera and show that what these are. But either way, I'm going to have to pull this one here out, and also the heatsinks were screwed in from the bottom, but also held in as well by the MOSFET screwing into the side of it. I would have thought just having it just with the MOSFETs would have been enough, since there's quite a few of them. But the real problem's obviously going to be fixing this problem here. Damn camera. So yeah, trying to fix that trace, and I'll have to give it a bit of a clean up and have a good look at that. So and try and get that part going. But yeah, so that's where I'm up to with it. And hopefully, this is obviously turning into far more of a pain than I would have liked. It's going to take up far more time than I would have liked, but it's going to be worth getting it going again, because if it's just those two components there, I have to buy them in a pack of 5 from our local supplier, but it does mean I can get them really quickly in the next couple of days, rather than getting them from overseas. And I'll replace both of these, obviously. Everything else looks okay, just visually looks okay. So the last thing I thought I'd quickly mention is, with this MOSFET removed, the short on the DC output is still there. So obviously the next thing to do is remove this one and see if the short is again still there. Hopefully just removing this one here and replacing both of these, the short will go away. But as soon as we remove this, hopefully the short stops, and then we know definitely there's nothing else that could be the problem. So I'll just remove that and we'll just quickly check that one. Right, so I've just desoldered that last one, and this is how it looks really. It came off, and I lost a leg, but that's okay. That was obviously the leg that was quite stuffed. But again, it's exactly the same MOSFET as before, as the other one was. So yeah, both MOSFETs blue, 33 amp MOSFETs. So they're only seeing 15 amps or so each, but yeah, maybe it was the heat. So what I've done is I've just put a multimeter on the DC output, and if I just do that again on camera, what you'll see, I just poke that into the correct side. Oh, how annoying. Get in there. Trying to do this one hand's a bit annoying, but as you'll be able to see, it's no longer a short. It looks like it's connected to a capacitor, and the capacitor is slowly charging up. So that's a really good sign. So that will hopefully mean that, well, what it would mean is that if we put everything kind of back together again, we should be able to turn it back on. It's not going to do anything on the DC side, but it'll most likely fire up, because everything else, all these other MOSFETs look fine, no shorts. Yeah, so really the next step is to buy another 2 of those, replacement ones for here, solder it back together again, somehow fix that trace. This is kind of how it looks on the second one, and this is how it looks on the first one. It's got a piece of it looks like double-sided kind of thick material that sat underneath the heatsink. Unfortunately, I have to somehow pull this off a bit, and once again, because it's like double-sided tape, it's stuck like anything. So I'm going to have to try and pull a little bit of that off to be able to see under it, to be able to figure out what that was actually, what that trace was actually doing. But either way, so there will be another update to this, obviously once I get those other 2 components in, and hopefully we can get the old thing, or get this thing fired back up again. So again, thanks again for everyone that commented on the last video. Obviously comment on this video if you've got any other suggestions and ideas that I should do. And yeah, thanks guys, and I'll see you guys in the next video.